Hello students. So as you know, we have started the 8th chapter, Electromagnetic Waves. Okay. So in last class we have studied about what are the electromagnetic waves, and we have studied how these electromagnetic waves are produced, and we go on for the properties of electromagnetic waves. All those things we have studied in our previous class. Okay. So today let's discuss some further things. Okay. So as you know, electromagnetic waves are there. You know how the nature of the waves will be. Means, for example, the waves simply the waves will be like this, propagating. Here we are having one quantity, let's take it as y, and in this direction x. In the direction of x, if the waves are propagating, they will possess some particular properties. You know it. There will be time period, there will be frequency, there will be voltage current. Sorry, voltage current is there in alternating current. In normal wave we will be having the time period, frequency, amplitude, and the angular frequency. All those things we will be having. Okay, so if this wave is propagating in this direction, okay, so as you know, we have discussed it in the alternating current chapter only. If it starts from here, it goes to one side, half cycle, and again here it will complete one full cycle, isn't it? So 0, 1, 2, 3, 4. In 4 points it will complete one full cycle. Okay, this upper portion, to this you call it as crust. This is called as what? Crust. And this is called as trough. You know it already. Okay, so distance between two consecutive crusts. Distance between two consecutive crusts. Let's call this as the distance, or the distance between two consecutive troughs. This distance is there not, to that we call as the wavelength. The distance between two consecutive crusts of a wave, or the distance between two consecutive troughs. Consecutive means what? Near, side by side. Side by side. Okay. Distance between two consecutive troughs or distance between two consecutive crusts is called as what? Wavelength. Okay. So this is one property of the wave. And also, if the wave is propagating like this, in 1 second, how much cycles it will finish? That is called as what? Frequency of the wave. Yes. So time period means the time taken to complete one full cycle. That is there. That is a common thing. Time taken to complete one full cycle is called as time period, and number of cycles completed in 1 second. Number of the cycles means this, from this to this, number of cycles completed in 1 second is called as frequency, and the distance between two consecutive troughs or two consecutive crusts is called as what? Wavelength. Okay, so commonly all the waves will be possessing these two properties. All the waves will be having particular wavelengths, and they should be having particular frequency. Okay, so this are electromagnetic waves also having wide range of frequencies and wavelengths. Understood? Electromagnetic waves are having wide range of frequencies and wavelengths. Understood? So depending on that, we have, if this is one full electromagnetic wave, this is one electromagnetic wave, it will be having so many ranges of frequency and wavelength. Depending on that, we can have, means up to here it will be having some frequency, up to here it will be having some different frequency. Next, change in wavelength, change in frequency takes place. Depending on their frequency and wavelength, the electromagnetic wave is separated into different regions. Means, if this is one full electromagnetic wave, at particular places we will be having different frequency, different wavelength, because I told you the I told you already that electromagnetic waves possess wide range of frequency and wide range of wavelength. So at different places of its wave, it will be having different frequencies and different wavelengths. So depending on that discrepancy, this electromagnetic wave is divided or separated into separate different regions. Depending on the frequency and wavelength, this electromagnetic wave is divided into separate regions, and to every regions we have given different names also. The different regions of different frequency and wavelength will possess different names also. So all of them are combined, they are arranged properly, and there will be a production of one spectrum. That only we call it as electromagnetic spectrum. So today we'll study about electromagnetic spectrum. Means the different regions of electromagnetic wave are named by given different names. To that we have arranged them in a particular order. That may be ascending order or descending order. So the proper arrangement of electromagnetic waves is nothing but electromagnetic spectrum. Understood? The proper arrangement of electromagnetic waves in different regions is called as electromagnetic spectrum. Understood? So depending on the frequencies and wavelength, we are having some types of electromagnetic wave, some different regions of electromagnetic wave. So we are having the gamma rays, then we are having X-rays, then we are having UV light, ultraviolet light, then we are having visible light, and then infrared rays, and then microwaves, and radio waves. Okay, so as I told you, the electromagnetic spectrum is the arrangement of electromagnetic waves in a proper order. Okay, so I have written this in a order of increasing wavelength. Understood? Radio waves are having the highest, longest wavelength, and gamma rays are having the shortest wavelength. So I have written this in the ascending order. Means here wavelength is less. From here it goes on increasing, and at radio waves the wavelength is maximum. Similarly, if wavelength is maximum here, frequency is less, because we know the relation lambda is equal to 1 by f. So here frequency is maximum and it goes on descending, and for the radio waves frequency is minimum. Okay, now let's see what are the frequencies and wavelengths of these particular waves. Okay, so these are the electromagnetic waves, and let's write their frequencies and wavelength. Here I will write their frequency, and here I will write their wavelength. Okay, so gamma rays are having the frequency 10 raised to 18 hertz to 10 raised to 22 hertz. You go on writing this table with me. In your book, you start writing this table. Okay, I will show you the electromagnetic spectrum later on. Just record the frequency and wavelengths of the particular waves first. Okay, go on writing. The gamma rays are having the frequency 10 raised to 18 hertz to 10 raised to 22 hertz. X-rays are having the frequency 18 hertz to 20 hertz, 10 raised to 20 hertz. UV light are having the frequency 7.45 into 10 raised to 14 hertz. I will not write the hertz, I will just give a hyphen, to 5 into 10 raised to 15 hertz. Go on writing the hertz. UV light are having the frequency 7.18 into 10 raised to 14 hertz to 5 into 10 raised to 15 hertz. Visible light is having a frequency 4 into 10 raised to 14 hertz to 7 into 10 raised to 14 hertz. Infrared rays are having 10 raised to 11 hertz to 10 raised to 14 hertz. And microwaves are having 10 raised to 8 hertz to 10 raised to 9 hertz to 10 raised to 12 hertz. And radio waves are having 500 kilohertz to 1000 megahertz. This is the frequency of radio waves. Okay, now look at the wavelengths of these waves. Okay, I'll write the wavelengths. Gamma rays are having a wavelength, shortest wavelength 10 raised to 10 meter to 10 raised to minus 14 meter. And next, X-rays are having a wavelength 10 nanometer to 10 raised to minus 4 nanometer. 10 nanometer to 10 raised to minus 4 nanometer. Ultraviolet rays are having 400 nanometer to 0.6 nanometer. Visible light are having a wavelength 400 nanometer to 780 nanometer. Infrared are having 1 millimeter to 700 nanometer. Microwaves 0.1 meter to 1 millimeter. And radio waves are having a longest wavelength of 0.3 meter to 600 meters. Okay, this is all about the values of wavelengths and frequencies of these waves. See here, gamma rays are having a frequency 10 raised to minus 18 10 raised to 18 hertz to 10 raised to 22 hertz, and the frequency lambda wavelength is 10 raised to 10 meter to 10 raised to minus 14 meter. The X-rays are having a frequency 10 raised to 18 hertz to 10 raised to 20 hertz, and they are having a wavelength 10 nanometer to 10 raised to minus 4 nanometer. UV light are having a frequency 7.5 into 10 raised to 14 hertz to 5 into 10 raised to 15 hertz, and wavelength is 400 nanometer to 0.6 nanometer. Visible light 4 into 10 raised to 14 hertz to 7 into 10 raised to 14 hertz, and the wavelength is 400 nanometer to 780 nanometer. Infrared rays are having a frequency 10 raised to 11 hertz to 10 raised to 14 hertz, and wavelength is 1 millimeter to 700 nanometer. And microwaves are having a frequency 10 raised to 9 hertz to 10 raised to 12 hertz, and wavelength is 0.1 meter to 1 millimeter. Radio waves are having a frequency 500 kilohertz to 1000 megahertz, and wavelength is highest wavelength is 0.3 meter to 600 meter. Note all those things in your book. You might not seeing it properly. That's why I told it. Okay. So as you can see here. From UV light is having 400 nanometer to 6 nanometer. Again, from that 400 only visible light is starting. 400 nanometer to 780 meter. Again, from that 700 nanometer only 1 meter the infrared rays is there. From that 1 meter to 0.1 millimeter to 0.1 meter microwaves are there. Means that's what they are not having the separating edges. Means if this is UV light and if this is visible light, they are like this only. Means they are not separated by a particular and sharp separation. They are just the regions. Means this is UV, this is visible, one more thing comes, this is like this, like that. They are not separated by the sharp boundaries. They are just the different regions. So how they have arranged all these waves in that electromagnetic spectrum? how the electromagnetic spectrum is arranged. Let's see. So see here students, I told you already that the electromagnetic spectrum is nothing but what? The ordered arrangement of electromagnetic waves. This electromagnetic spectrum is nothing but what? Ordered arrangement of electromagnetic waves. Okay, as I told you, they are having the different regions with different names. So here what I am doing, I have written the frequency in hertz in this direction, frequency in hertz in this direction, and at the below region I have written the wavelength. I have written the wavelength there in this direction, wavelength in meters. Okay, so now see here, in this region from 10 raised to 23 to 10 raised to 19, I will write the gamma rays, which are having the shortest wavelength, gamma rays. Okay, next, so what is the wavelength of X-rays? We have written already, 10 raised to 18 hertz to 10 raised to 18 hertz to 10 raised to 23 hertz, from 18 to 23. So I will write here in this region I will write the X-rays. Next, continuing here from 15 to something about 17, I will write the ultraviolet UV rays, and here I will write the visible light. Okay, next here I will write the infrared IR, infrared rays, infrared region. Okay, so next here I'll write the microwaves, and at the last we are having the radio waves. Okay, so this is how the electromagnetic spectrum is there. Don't worry much about these values, okay, that they are, we have written it approximately, but you know the exact values of frequencies and wavelengths, right? So here we have arranged all these these gamma rays, X-rays, UV, infrared, micro, radio, visible, all are what? Electromagnetic waves only. But that electromagnetic waves are having what? Different frequency and different wavelength. That's why they have arranged it in an particular order. This ordered arrangement of electromagnetic waves of different regions of different names is called as what? Electromagnetic spectrum. Understood? And these regions are not having any sharp boundaries. They don't have any sharp boundaries. Okay, so this is all about electromagnetic spectrum. Okay, so let's see in brief about particular electromagnetic waves, means a bit about every electromagnetic wave. So let's start with the gamma rays, which is having a shortest wavelength. I will discuss them about in brief. I'll discuss about every electromagnetic wave. So let's start with the gamma rays. Okay, what are gamma rays? So these gamma rays are produced by electron jump from higher orbit to the lower orbit. Means like this, if orbits are there, you know, from around the nucleus the electrons will revolve in the orbits. Okay, so when electron jump from higher orbit to lower orbit, when electron jump from higher orbit to lower orbit, at that time gamma rays are produced. Understood? Gamma rays are produced when electrons are jumping from higher orbit to the lower orbit. And also they are produced during the radioactive decay. These all things are very new for you. Don't worry much about them, just remember the name. Okay, and already you know the gamma rays are having the frequency. Gamma rays are having the frequency of the range 10 raised to 18 hertz to 10 raised to 22 hertz, and they are having a wavelength of the range 10 raised to 10 meter to 10 raised to minus 14 meter. Understood? And these gamma rays are having highest penetrating power. Highest penetrating means if you hit the gamma rays on any object, if this is my hand and I am hitting the gamma rays, they will penetrate at higher intensity. Understood? Means penetration power of gamma rays is higher. So about gamma ray, just keep in remember 2 to 3 points. That is, gamma rays are produced when, first point is what? Gamma rays are produced when electron jumps from higher orbit to the lower orbit, and also they produce from the radioactive decay. Second, their frequency is like this, their wavelength is like this. Okay, and they are having the higher penetration power. Understood? Okay, so this is about what? Gamma rays. And these gamma rays are discovered by the scientist Willard. So these 2 to 3 points you can remember about the gamma rays. Moving on to the next we are having X-rays, right? X-rays. Okay, after gamma rays we are having X-rays. These X-rays are discovered by William Röntgen. You have studied in this in the high school classes only. William Röntgen in 1895. William Röntgen discovered the X-rays in 1895. Okay, so what are these properties of X-rays? How they are produced? They are produced by bombarding a high atomic number with a beam of fast moving electron. That means what? If we are having means any one atom with a higher atomic number means the Z should be maximum. Okay, so this atom of higher atomic number should bombard. That means what? They should get bombard means collide with one beam of fast moving electrons. Means the beam of fast moving electrons, if it is bombarded with the nucleus of higher atomic number, the X-rays are produced. How X-rays are produced? They are produced by the bombardment of fast moving electron beam and the nucleus with higher atomic number. Understood? You already know its frequency and wavelength. I won't discuss much about this. And one more important thing is you have already seen the X-ray scanning in the hospitals. Whenever you got any fracture of the bones or anything, if they want to see your bones, they will do the X-rays. Why? Because our skin is there na. Upper side we are having the skin, below that we are having the flesh, below that we are having what? Bones, isn't it? So gamma rays can penetrate through the skin, can penetrate through the flesh, means this is skin, they can pass through the skin. This is flesh, they can pass through the skin, but they are stopped by what? Bones. So when they are penetrating on the bones, they came back. Understood? Means like this, you consider this is a skin, this is flesh, this is bone. Skin, flesh, bone. So they will pass through the skin, they will pass through the flesh, but they are stopped by the bones. When X-rays are hit on the bones, they will reflect back. That's why to detect any problem in the beam in the bones, they will use the X-rays. Understood? And also they are more dangerous also. If you expose your skin for a longer time to the X-rays, you may get skin damages. So that is dangerous also. So X-rays are discovered by the scientist William Röntgen in 1895. They are produced by the bombardment of higher electron, beam of higher electron, when it is bombarded with the atomic the nucleus with the atom into the higher atomic number, and they are passed by the skin, they are passed by the flesh, but they are stopped by the bones. This is all about what? X-rays. Moving on to the next. What is next? We are having ultraviolet light. Ultraviolet light. Okay, you already know about frequency and wavelength of ultraviolet light. These ultraviolet rays are produced by the sun. The main source of ultraviolet rays is what? Sun, or also some welding arcs. Means in the mechanical shops they will be having welding arcs na, there also they can produce ultraviolet light. Okay, but this ultraviolet light or ultraviolet rays are very dangerous for the human being. If you expose yourself for ultraviolet light for a longer time, you may get the cancer also. Or otherwise, in the sunlight there will be ultraviolet rays obviously. So that's why when in summer if you go outside for a longer time, you will get the tan on your skin, isn't it? The tanning of the skin is due to the ultraviolet rays, and this ultraviolet rays will harm the melanin in our skin. In biology you may have studied, in the skin will be having something like melanin. So when you expose yourself to the ultraviolet rays, that ultraviolet rays will harm the melanin of the skin. That's why the skin got tanned. And also there is a fear of cancer also if you expose yourself more for the UV light. Understood? You might already know this, the fact that the ozone layer is there na, that ozone layer will protect our earth from the harmful ultraviolet rays coming from the sun. Okay, so this ozone layer is protecting us, but nowadays you already know that ozone is depleting because of the CFCs, chlorofluorocarbons coming from the fridges, ACs, isn't it? The ozone is also getting depleted. Don't know who will protect us from the harmful UV light then, isn't it? This is a thing to be think on. Okay, so next, moving on, the visible light. Fourth one is what? Visible light. So as you know, you have already know the frequency and wavelength of visible light. So visible light is nothing but what? The thing which is visible, the light which is visible for us, because this X-rays, gamma rays, UV, infra or radio, micro, we cannot see them. So whatever the light it is visible for our eyes is nothing but visible light. Understood? So this visible light is just the thing which will create the sensation for the human eyes. Means human eye, the sensitivity of human eye means whenever you see an object, whenever if you want to see any object, the light should fall on that object, then only you can see that object na. So that light responsible for that process is nothing but what? Visible light. Understood? So that is having the frequency of 4 into 10 raised to 14 hertz to 7 into 10 raised to 14 hertz, and the wavelength is 400 nanometer to 780 nanometer. You know this already. Okay, next we are having which one? We are having next one is fifth one. Yeah, fifth one is infrared. This is also coming from the sun only. Infrared waves, they are having how much frequency and wavelength they are having, you know it already. they are produced. How the infrared waves are produced means excitation of atoms and nucleus. The infrared rays are produced by excitation of atoms and molecules. Excitation of atoms or molecules means whenever a molecule is at rest, when it get excited, if you give it any external force, or if you give it any external agent, so that get excited. So this infrared waves are produced by the excitation of atoms and molecules. Or also hot bodies will produce infrared rays. Sun is also a source of infrared rays, and this infrared rays can also called as heat waves because they are produced by the hot waves also, hence it is called as a heat wave. Understood? So moving on. Yeah, these infrared waves are discovered by the scientist William Herschel. William Herschel. Okay, this is one more point. Next, microwaves. Microwaves. What are microwaves? The wavelength and the frequency is already known to you. Okay, how these microwaves are produced means they are produced by oscillating electrons. Microwaves are produced by what? Oscillating electrons. Microwaves are produced by oscillating electrons, or also uh, like accelerating electrons. Understood? So this is about microwaves. Okay, next we are having radio waves. Radio waves, as you know, radio waves are discovered by the scientist Marconi. You know it already. Okay, so this, how these radio waves are produced then? They are produced by the electric current in the LC circuit. They are produced by the changing electric current in the LC circuit. Okay, the wavelength of radio waves is not only one thing, means 500 kilohertz to 1000 megahertz, I have told you, but they are separated in their own passion, like very high, very low, like that, very high, very low, low, like this. Means we are having the different types, different like low frequency, wait, low frequency waves, high frequency waves, medium frequency waves, very high frequency waves, and very low frequency waves. Like that we are having the different regions. Okay, I will give it all in detail in the notes also. This is just to remember the things. Okay, so this radio waves, as you know, they are mainly used in the communication system. The uses of every waves we will study in the next class, but so this is all about the electromagnetic spectrum. Understood? This is just the ordered arrangement of the electromagnetic waves with respect to different frequencies and wavelengths, and we have studied about in brief about particular waves. Okay, in notes I will write it in detail. Okay, in the next class we'll do some problems.